built Agentic system on the Raspberry Pi at the weekend. Did 4 videos. So my whole concept behind everything is to let people learn AI for free or next to nothing. So if you don't have Raspberry Pis, so I took 2 8 gig Raspberry Pis to run it. It might have fitted on one. What I decided to do was, some people have got laptops and just use some resources on your laptop to build it using Vagrant and VirtualBox. So I have built the same system, or a very similar system, and I'll add the Vagrant file to the YouTube video so you can install it. I did do an export of the N8N config at 6K, so I don't think that can get appended in the end. But I'll put it up on Enzo's dad. I'll get around to making the website, and the file will be able to download. But I think it's more fun for you to actually try the N8N stuff. But it's documented well. So this is going to be much faster track than the 4 iPad videos, Raspberry Pi videos, because I try and fit everything into roughly a 10-minute video. So I have a networking video, but presumably your network's going to be 192.168, and then it's going to be a 0 or a 1.25, and I'm going to use .253. So the networking video will explain it more. But if your network at home is 192.168.1, you don't need to do anything. You just need to run it as. If you have a 192.168.0, then you have to change the 1 to 0 in the Vagrant file in these 2 locations in pink. Or if you're using a Mac, you install iTerm, VirtualBox, Vagrant, and the Vagrant utility driver. If anytime you patch, you have to reinstall it, because they're quite susceptible to getting changed. So I use Vi as my text editor on a Mac, so I just sudo Vi. But any text editor you want, and you want to append whichever, if you're a 0 or a 1 in the 192.168, 0 or 1, 253, and then just put AI on Pi and AI on Pi.local. So that's just so your machine knows where your virtual machine is, because we're going to connect the browser to N8N from your main machine to your wee server you've just built as a virtual machine. So this is the only thing you need to do on your machine. And if you're on Windows, instead of iTerm, it's Putty you would use as your client, and your host file, Notepad to text editor, use a Windows. I'm sure there's a more appropriate one these days. And the host file is in the C: Windows System 32 drivers, etc. host file. So you just add the same entry if you're on Windows. So the Vagrant file, what does it build? Well, at the top of it, I've set it to be 12 gig with 8 virtual CPUs. I've built this on a MacBook Air, and I've built it on a Mac Studio. So it's a 16 gig M1 MacBook Air. So it ran fine on that. If you've got less than 16 gig, you might be able to get away with running 8 gig, but it's going to be a big virtual machine. So I set the IP address. You can see 192.168.1.253. So the Vagrant file builds everything in here. So it installs a Llama. It builds it up with Ubuntu. It installs a Llama, which is your model driver. It runs your models, and we use 4 models. We might actually not use a Gemini. I think we've installed it, but don't use it. But we install Llama and Nomic definitely. So we use at least 2 of the 4. And we install Podman, which is the same as Docker, but it's sort of license free, so it's the better one for what we're using. And then the Docker container images we install N8N, which is the Agentic workflow, Nginx, which is a web server, V8 we don't use, but we install it, which is a vector database. Quadrant is also a vector database, which is the one we use. And we've got Mongo as a NoSQL database that we don't use. We've got Maria and Postgres, which are region databases that we don't use as well. But because we're going to use it in future videos, it's a good basis, so that's why they're still present. So hopefully that makes sense. We just run the Vagrant file and it all works. So as you can see, we've done some timing. So it takes 58 minutes to build on my MacBook Air, which was in the caravan, and it takes 11 minutes at home on the the Mac Studio. But I think it's more to do with internet speed than the power of the machines. And these are just snippets from the builds. So we get some Ford manuals and we copy them in as PDFs, and then you can see Alama's got 4 models listed. The bottom line is a good diagnostic, so I curled the Nginx web server, and then you can see that the whole world comes back, so you know the web pages are working, but so you know Podman's working, Podman Compose is working, and it's all very good work. And then you can see that the NAN, which is in port 5678, doesn't work. So it's all part of the troubleshooting fun. And then on the right hand side, we've got Podman PS and sudo Podman PS. We've managed to get everything working as Podman in the build. We don't need to sudo to root. But if in the previous incarnation, we sudo to Podman root, and we could see that everything was running. Okay, and this is another snapshot of just Podman's now running as the Vagrant user, so we don't need to do sudo to get involved root. So it was all getting better. So yeah, it's four images in Olama, and Podman's running a bunch of processes. And it takes roughly 11 minutes to boot up from this file. It takes about an hour on my MacBook Air. I presume the internet in the house is faster. I think that's going to be the main differentiation. So what we've done is we've just done a Vagrant up, we've timed it, and that's why it shows 11 minutes. But we can see I went to the browser first, and the website wasn't there. Well, I went straight to N810 and it wasn't there. So we can see it's come up, but the website's not there. So what we'll do is we'll log into the VM. So that's Vagrant SSH. I'll let you into the VM. And then we're just going to do a Podman stop and start. Podman compose -f compose.yaml down. And that stops everything. And then we'll do an up -d. The images should have downloaded during the build. I don't know why it's not working all the time. It's not consistent. Sometimes it does work and sometimes it doesn't. So if I go curl http now I'm not in my laptop my desktop window, I'm in the virtual machine window, but on pi.local :8090. That's our whole world working. So all we did was went in to the Podman stop and start. Let me see if I can get Safari in this window, and I wanna let's see. I've got Safari there. So let's see if I can go http://ai on pi.local :5678. Oh, right. Got a little bit more troubleshooting to do to see why that didn't happen. Let's move this out of the window, and what we can do is we can do post. Then no, it's not. It's Podman. Podman logs NAN, and it's going to be a message about start, isn't it? Oh, it thinks it's working. Okay, so it turns out that I hadn't edited the host file on my Mac Studio, whereas it worked fine on my MacBook Air, and obviously it worked fine in the Mac Studio when I amended the host file. So the commands we've been using are Vagrant up, which just reads the Vagrant file and brings everything up. Then to do the troubleshooting, we did Vagrant SSH, which logs into the box, and then I did the Podman compose down, and then Podman compose up. So it's much quicker because the build where you're going away and have a cup of tea or ignore it for an hour or 11 minutes, depending on the speed of your internet. That was enough to bring everything into life. So you can see on the right hand side, the Vagrant build's just finished. We've done a Podman compose down, Podman compose up, and then on the left hand side, the N8N windows there. And the Raspberry Pi videos, there's steps. I think it's video 4, the last one, 4 out of 4. There's steps on how to do it, and then just the commands are exit. And then I do Vagrant destroy -F, which just wipes everything, doesn't retain everything on on your machine at all. I love the clean environment, so you can muck about and do whatever you want. The downside of using the VMs is we're just using the CPU given to the virtual machine. We're not using any of the Apple Silicon GPUs. So if we ran it on the Mac, we could do clever things that uses the GPU, but just now everything's just CPU and it's all good. Okay, so it's the same one as we did in the Raspberry Pi video. What we do is we click execute, and that reads the files that we've copied in. So it's some Ford manuals, 5 Ford manuals from and that goes into the N8N file, local file location. So that's what that talks to. And when you build N8N, we'll do future videos, but there's all automated ways of building these pipelines, and what you actually do is just connect it to the bits. So Quadrant Vector Store is a Quadrant database, and that's just Quadrant, and it uses the Quadrant data on top of Podman. The embeddings for Llama, we're using Llama and we're using the Nomadic model. And then when we do the chat, we've got a chat agent going to an AI agent, and that uses a Llama with Meta's Llama. And for the Quadrant Vector Store, again, it's Quadrant. So it's all pretty simple and all good. So what we did was we set up the Quadrant, and as you can see, the connectors. So we just connected it to HTTP AI-on-Pi.local, and the port is 6333. So that's all we did to connect Quadrant, and then we set up a car info collection, and then in the features time we retrieved from it. So the same file. The N8N, we just used the disk location that we set up earlier, which is /file/Ford. So that's where we took the PDFs from. And on a Llama, all we need to do is set up the connection on HTTP AI-on-Pi.local, and it's 11434. So we don't need API keys for anything because we're all local and we're running all insecure, but it's all part of their learning. So here's a screenshot of it loading up, and it did it much faster than the Raspberry Pi. It did it in a couple of minutes as opposed to 19 minutes. But what it did, it extracted the Ford manuals, 5 Ford manuals. The embeddings chunked it up to easy readable things, and they're stored in the vector store. So that was workflow 1, and workflow 2 was the agent. So you can see I've asked it what's the correct tire pressure, and it went away and processed it for quite a while, slower than I was expecting. But again, we didn't use the GPU, the Mac, and it comes back with the answers that it's not in the output, but the tire pressure is typically found on the label in the driver's side B pillar of the vehicle, which is a good enough answer. So rather than buying Raspberry Pis, it's possible if you've got enough capacity on your laptop, your desktop, to run this as well. So thanks very much. Hope you get into AI, and it should be free. You don't need to learn much. Just use YouTube, and thank you.